Okay, this is an overview of the alkanes, topic C7, lesson 1. So alkanes can come under the title of organic chemistry, and that simply means that these things are carbon based. So all of the alkanes start with carbon, and the reason carbon is used is because it's such a versatile atom, because it's got 4 electrons in its outer shell. It's got in its second shell, and the reason being is that it then needs to form 4 other covalent bonds to fill it up. So it can form 4 single bonds, it can form double bonds. It's a really useful atom to make sort of a scaffold to then build much larger molecules. So where do we get these carbon-based molecules from? Where do we get these alkanes from? Well, they originate in crude oil. So crude oil is simply the remains of ancient biomass, once living things, plants, animals, that kind of thing. In particular, something called plankton. So these are tiny microscopic plants that lived in the sea and the oceans, and once they die, they sink down to the bottom and they collect and build up, and over millions and millions of years they're put under immense heat and pressure as more and more layers of rock build on top of them, and eventually they molecules break down into hydrocarbons. And just like the name suggests, hydrocarbons are made from hydrogen and carbon only. So let's have a quick look at some of these. So the first set that we're going to look at is the first 4 of the alkanes. Let's name them first. We've got methane, we've then got ethane, propane, and then butane. Methane is made from 1 carbon, ethane is made from 2, propane is made from 3, and butane is made from 4. There are others. It goes on to pentane, hexane, and so on as well, but we're only going to do the first 4. These are hydrocarbons, so they also need to have hydrogens as well as just the carbons, and the formula for methane is CH4, ethane is C2H6, C3H8, and C4H10. And yes, you do need to know all of these. I'm going to show you how to draw them. It's really simple. Let's do it in stages. 1 carbon, 2 carbons, 3 carbons, 4 carbons. So we've got the carbon backbone of each one of these molecules. Remember, each one of the carbons can form 4 covalent bonds. So let's add these in for the first carbon. 1, 2, 3, 4. Let's add it in for here. 1, 2, 3, because we've already got one. Carbon number 2 already has one, so 1, 2, 3, 4. Let's look at carbon 1 over here. We've already got one, so we're going to add another 3 to make it 4. The carbon in the middle already has one on each side, so it only needs 2 more. And this carbon on the end here already has 1, so we're going to add another 3, and that fills that up. And again, you can see the pattern emerging here. If you count each one of the carbons, they have 4 covalent bonds. And on each one of these, you would draw or write a H for hydrogen. So I'm just going to do the first 2, just so the diagram doesn't get too complicated, but you get the idea. So you can write H's on all of these other ones. So you can see the molecules get bigger and bigger and bigger and bigger, and each one of these would have a hydrogen attached to the end of it as well. So these are all hydrocarbons. Now, all of these alkanes all end in the word ane, so that indicates that it's an alkane. And the first part of the name tells us which part of the series they belong to. So when we talk about a series, we talk about sort of a list or a sequence or a group of molecules that are not identical but have got really similar features. So you might use the word homologous to describe this. We call it a homologous series. Now, the word homo means the same. So they're the same because they all end in ane, they've all got carbon, and they've all got hydrogen. Logos means series, homologous series, or means in proportion, sorry. So what have we got in proportion? Well, there's a relationship between the number of carbons and the number of hydrogens. It might not be obvious straight away, but let me just tell you what that is. We need to use a little bit of algebra to explain why they're in the same proportion. We can use the formula CnH2n plus 2. This is called the general formula. The general formula is a way of trying to calculate the number of hydrogens based on the number of carbons. So let's see if all of these molecules here are all of the same proportion. Have they got twice as many hydrogens plus 2 more compared to the number of carbons? Well, let's have a quick look. Let's do ethane. If we were to use this, we'll do 2 examples. C2, H, 2 times 2 plus 2. 2 times 2 is 4, plus 2 is 6, C2, H6. Let's have a quick look. C2, 1, 2, 3, 4, 5, 6. Formula works. Let's try one more. We'll do butane. So now we've got C4, H, 2 times 4 plus 2. 2 times 4 is 8, plus 2 more is 10. So C4, H, 10. Let's quickly count them all up. 1, 2, 3, 4. Then we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Formula works. So the alkanes belong to our carbon-based molecules. They're made from only hydrogen and carbon, and they originated from crude oil. There's 4 that we need to learn from the start of the series, going from smallest, and they slightly get bigger and bigger, or longer and longer, as we add an extra carbon. They all end in ane. We need to learn the prefixes for each of the words, and they belong to the homologous series, which means that they're the same because they all contain carbon and hydrogen, and they're all in the same proportion because there's a relationship between the number of carbons and the number of hydrogens for each one.